All right, I neglected to do the final proof in the previous video, so let's do the final proof together. And I'll do it the same way that I did the others. That is, I'll talk a little bit about the proof, just the setup, and then I'll suggest that you pause and do it yourself, and then we'll do it together. All right, so here's what we've got. The diagram that looks very much like the previous diagram. I think it's identical, actually. And in this case, we're told that C bisects both AE and BD. Okay, so segment AE gets bisected. So we have two equal parts there. And segment BD gets bisected as well. So we have two equal parts, as I have just marked. And then we're told that the measure of angle FCA, which I will have reason to call angle 1 later on. And you're always free to do this. You can relabel angles if you like, and then make use of that relabel. Just make sure that it's clear in the diagram what you've done. So we're told that, again, the measure of angle FCA is equal to the measure of angle GCD, which I will call 2. Okay, so those angles are equal to one another. And then we wish to prove that BF is equal to GD. So before you try this, just keep in mind, and let me point arrows at what we wish to prove equal. Keep in mind that probably what you'll do is prove triangles congruent and then use CPCTE. And what are the triangles that you will prove congruent? Likely BFC and DGC. So you can think about how it is that you would prove those congruent to one another. All right, so try it yourself and then come back and we'll do it together. All right, so let's do this proof together. So we wish to prove again that BF is equal to GD. So my goal is to prove that triangle BFC is congruent to triangle DGC and then use CPCTE. Well, in those two triangles, I know that BC is equal to CD already. Okay, or I will once I say that in the proof. That follows from bisects. So that's a side equal to a side. And then, notice this as well, that of course angle 2 will equal angle 3 by the VAT. So we'll have an angle equal to an angle. And then if we could get FC equal to CG, we could conclude that triangle BFC is congruent to triangle DGC by side angle side congruence. So really the goal here initially is to prove that FC is equal to CG. And how to do that? Well, probably CPCTE. So what two triangles could we prove congruent that would allow us to then conclude that FC is equal to CG? Well, I suggest that we attempt to prove that triangle AFC is congruent to triangle EGC. Okay? So how would we actually be able to do that? Well, do note that angle 1 is equal to angle 4. Okay, so the angle there that I will there call 4. So angle 1 is equal to angle 4. So that's a pair of equal angles, and AFC and EGC. And we also had that AC was equal to CE, so that's a pair of equal sides. And then what else could we use? Well, notice this as well, that angle A, which I'll continue to call angle A, must be equal to angle E. And why must that be true? Well, consider triangles ACB and DCE. Those are different triangles that I've considered up to this point. Again, they are ACB and DCE, or rather I'll call the second ECD. Those are congruent by side angle side congruence because there's lots of VAT actually. So all of angle ACB is equal to all of angle ECD by VAT. And then we also have two pairs of equal sides equal, two pairs of corresponding sides equal. So it will follow that triangle ACB is congruent to triangle ECD by side angle side congruence, from which it'll follow that angle A is equal to angle E by CPCTE. And then we will be able to say by angle side angle that triangle AFC is congruent to triangle EGC. From that, it will follow that FC is equal to CG, which is what we wanted it to start by CPCTE. And then once we've said that, we'll be able to say that triangle BFC is congruent to triangle DGC by SAS congruence. And then we will be able to say finally that BF is equal to GD by CPCTE. Okay, so I tell you what, actually, I've gone back on what I said initially. I think this one might be clear, so we give it as a column proof. And again, you're free to make up your mind about the kind of proof that you will give, either a column style proof or a paragraph style proof. I think I'll give a column style proof in this case. So we have the given. And at the very end, I'm going to come back and say something about the setup of this proof, because actually I think the given has more information than was actually strictly necessary. So we will see. So we will see whether that is the case. I suspect that it was. Okay, so let's see. So what did we need? Well, we needed that AC was equal to CE, right? And likewise, we needed that BC was equal to CD, that for sure. And that follows from the given, of course, by the definition of bisects. Bisects means always cuts into two equal parts. Okay, and let's see, what else did we need? Well, we wanted to prove that triangle AFC was congruent to triangle EGC. So we needed that the measure of angle 1 was equal to the measure of angle 4. And that followed from 1. The given just includes the diagram, and the diagram tells us that we have vertical angles, of course. So that's by the VAT. Oh, and then we were also going to need angle A equal to angle E. And how do we get angle A equal to angle E? Well, by CPCTE. Okay. Apply to triangles ACB and ECD. So to get there, we needed that the measure of angle, and here we really need 3 letters, otherwise it would be really super unclear what we meant. So the measure of angle ACB is equal to the measure of angle ECD, which again follows from the given, which is just our diagram and what we're told about it by the VAT. And now in those two triangles, namely ACB and ECD, we have 2 sides equal to 2 sides, and then we have the included angles equal as well. So it now follows that triangle ACB is congruent to triangle. And notice we have to get the correspondences right. So the second has to be called ECD by SAS congruence. Okay. And then where were the equations that we needed for that? Well, we needed AC equals CD and BC equals CD. So that was line number 2. We needed the included angles equal as well. That was line number 4. And then we are now allowed to say that the measure of angle A is equal to the measure of angle E. That follows from line number 5 by CPCTE. Those are angles that correspond. So look at that. A is first, D is first, so they absolutely correspond to one another. And then, well, let's see. Why were we able to do that? Why do we want to do this? Because we wanted to be able to say that a triangle ACF was congruent to triangle, I'm going to call it AFC, is congruent to triangle EGC. And are we able to do that? Well, yes, I think we are able to do that. I'll tell you what, let me put dots inside of those triangles to call attention to which ones we mean. So AFC congruent to EGC. So are we able to do that? Yeah, we've got the side AC equal to the side CE. We've got a pair of equal angles at A and at E. And then we've got a second pair of equal angles at 1 and at 4. Okay, so those two triangles are congruent by angle side angle congruence. Yeah. So we can now declare that triangle AFC is congruent to triangle EGC by angle side angle congruence. And let's make sure we get all the lines that we need for this. Well, we needed angle A equal to angle E, which is 6. We needed angle 1 equal to angle 4, which is 3. And we needed AC equals CE, which was line number 2. Okay, so that's what we used, ASA congruence. And why do we need to do ASA congruence? So that we could get FC equal to CG. Okay, so I now believe that we can say that FC is equal to GC. And yeah, sure enough, FC second third, GC second third. So that follows from line number 7 by CPCTE. CPCTE. And then let's see, remember, just remind us of what we wish to do. What we're supposed to prove here is that BF is equal to GD. So to make that happen, we needed that triangle BFC was congruent to triangle DGC. And then, well, let's think about what just happened. I just said that FC was equal to CG. I'll go ahead and mark that in because it's been proven true. And then, let's see, those two triangles, we're very close to being able to declare them congruent to one another by side angle side congruence. We do need to go ahead and note, however, that the measure of angle 2 is equal to the measure of angle 3. that follows from the given by the BAT. And the reason we need that, of course, is that that's the A in side angle side congruence. And now we are able to say that triangle BFC is congruent to triangle DGC by SAS congruence. Okay. And then let's see, what does that follow from? Well, we needed the measure of 2 equal the measure of 3. That is the A in side angle side. We needed BC equals CD. That comes all the way back on line number 2. And we needed FC is equal to GC. That comes back on line number 8. And then once that is the case, we can say that BF is equal to GD by CPCTE. And the proof is complete. So that's kind of a hard one. Oh, yeah, and the point that I wish to make, there's something in the given. I just realized this as I work through this. And it gives me an opportunity to make a kind of logical point, I suppose. It occurs to me that I never made use of the fact that the measure of FCA is equal to the measure of angle GCD. That doesn't have to be true. That's not needed in the proof, okay? It is true apparently because it's given, but it's not used. Typically, you will use everything that has been given to you. My intent usually is to only insert into the given what is absolutely necessary to reach the conclusion. However, there might be cases where I make a mistake along the way, and it's possible to reach the conclusion with only a portion of the given. Okay, but that is something that you should keep in mind as you do your proofs. You should be suspicious of your proof if there's some portion of the given of which you never made use. Now, it could be that I did mistakenly insert something into the given that wasn't really needed, but typically I get that right. So typically, if you produce a proof that doesn't use some portion of the given, typically that means that your proof is incorrect, though not always. All right, so we are done.